The last thing that we're going to look at in this section is what we call end behavior. So as the name suggests, we are going to look at the ends of the graph. So I'm going to kind of skip over the constant function because it's kind of an outlier almost from the rest of them. So I'm going to start with the degree of 1. I'm going to focus on the odd degrees first and come up with a general consensus. So when I look at odd degrees, I see that this end is going up and this end is going down. On this one, going up and going down. And I got one more going up and going down. I know I circled those backwards, but general consensus is that if I have an odd degree function, then their ends are going to finish opposite. One will go up and one will go down. Now, if I have an even degree, I got a couple of them that are even degrees. Here's an even degree. Notice where these are both finishing. Those are both finishing down. And on the fourth degree over here, they're both finishing up. So in a general consensus, if I have an even degree, then my ends are going to finish in the same direction. They're either both going to go up or they're both going to go down. Next, some other interesting scenarios that we can come up with is the relationship of the degree and the number of zeros. So in this case, we're strictly focusing on real solutions, but I could incorporate imaginary into this as well. So if I look at a degree 1, I want to know zeros. Remember, zeros or solutions or roots, that's where it crosses the x-axis. So here, I see it crosses the x-axis once. On a degree 2, it's crossing it twice. Degree 3, crossing it 3 times. Hopefully you're starting to see a pattern now. Degree 4, it's crossing it 4 times. Degree 5, it's crossing it 5 times. Now, I don't have to have 5 real. If I have a degree 5, I don't have to have 5 real solutions. We'll talk more about this in a later section. I could have some imaginaries, but the degree will also tell me how many zeros or solutions I could have or will have. How many zeros you will have. Again, we will just focus on real solutions for today. We won't deal with, we will not deal with any imaginaries. I got some examples that we're going to do over here. I've got 4 parts to each problem. I want to first describe the end behavior, determine whether it represents odd or even degree, state the number of real zeros, and then we'll finish by trying to determine whether the leading coefficient is positive or negative. So let's first describe the end behavior. Describing the end behavior is a sentence using a lot of symbols. So I have to come up with 2 sentences because I have an end here and I have an end here. So I'm going to describe this end first. And the sentence that's going to incorporate or describe this end to the left is going to go as follows. As x goes to negative infinity, f of x goes to infinity. So what does this mean? Well, as I put in big negative numbers, or as I'm going left, that's what the first part is saying. As I put in x values that are negative, going left, my graph is f of x, is going up. So if it's going up, I have positive numbers. Do the other one over here as well. So as, to represent this side, we're going to say as x goes to positive infinity this time, because now I'm going to the right, I'm putting in positive x values, f of x, so my graph now is going down, which means I need negative infinity values. This is how I would describe my end behavior. Part B wants to know whether it represents an even or odd degree function. I already kind of talked about this on the previous slide, but if my ends are finishing in different directions, notice I'm going up over here and down on this side, then that represents an odd degree. Part C wants to know how many real solutions, so how many times is it crossing the x-axis, should come up with 3 real solutions. And then part D wants to know whether it represents if the leading coefficient is positive or negative. The easiest way to determine this based on a graph is to really look at this side. So if my graph is going down on this right side over here, then I know that the leading coefficient is going to be negative. If it was going up, then it would be positive. Okay, so that's the first one. I'm going to do the other one as well. That way you have 2 examples to kind of go off of. And I'm going to erase all of this. So now looking at this one over here. To describe my end behavior again, we're going to say as x goes to negative infinity, as I go left, my graph, f of x, is going to negative infinity. It's opening down. My other end, as x goes to infinity, now we're going to the right, f of x is going to negative infinity because it's opening down. Part B, this time it is an even because both ends are finishing down. Remember, if the ends finish in the same direction, that makes it even. C, how many real zeros do you see? This time it's only crossing the x-axis twice, so there are 2 real zeros. And then part D, if it's an even function, I think trying to determine the leading coefficient is a little bit easier because now they're both going down. Since it's opening down, we know that it has to be a negative leading coefficient. Again, if they were both opening up, then it would be a positive leading coefficient.